Welcome e-learners, this is 9.5, the third video from the homework. I intend on wrapping up through 85. Hopefully all goes well here. It is 2020. I don't know, maybe I should have a day count. We're deep into the coronavirus issue right now. Hopefully everyone's doing well at home. Hopefully we get back to school at some point soon, but there's a reasonable chance you're watching this one from home, 9.5. So we're to convert from polar equations to rectangular forms. Polar equations are going to have r's and thetas, and of course rectangulars will not have r's and thetas. They'll just have x's and y's. And our two strategies will be turn trig functions into their 2am ratios, like sine is y on r. And if we have an r squared, we can turn that into x squared plus y squared. Some people rush to this. They'll see a problem like 65 and they'll go ahead and just square both sides first to get that r squared. But let's deal with this sine first. So we're going to have r equals 4 times y on r. And now if I multiply both sides by r to get rid of this fraction, I get r squared equals 4y, or x squared plus y squared equals 4y, which really isn't too bad. But I'm recognizing right now that appears like it is probably a circle with the positive x squared, positive y squared. So I'm going to try to write this as the formula circle in standard form. So we get x squared plus y squared minus 4y. I'm going to leave a blank here. You'll see why. I want to complete the square on the y's. So half of negative 4, negative 2 squared plus 4, balance it, plus 4. And I get x squared plus y minus 2 squared equals 4. And that's probably the best way we should represent this equation, because as I often say throughout the year, this really tells the story of what that function is. So kind of surprising that we could take a graph that typically in rectangular form, sine, looks like this, on and on and on. But as we rotate and throw the rock in this polar form, it just becomes a circle shifted up 2 with radius 4. Okay. If you are just given an equation that only has theta or only has r in it, you'll see one with just r soon, then my strong recommendation is, hey, let's just draw a picture of this. Theta is 5/6 pi. Which means I can throw the rock however far I want to, but I have to rotate and be facing 5/6 pi, which could be represented something like this, where this would be 1, this would be 2, this would be negative square root of 3. So I'm aiming this direction. I'm throwing the rock this direction, but don't forget, r could be, I could throw the rock any distance I want, including negative distances. So the graph of theta equals 5/6 pi is just this entire line. I just need the equation of that line. To get an equation of a line, a little technical difficulty on my end here, sorry. I'm back. To get the equation of the line, I just need a point that it passes through. Well, it passes through conveniently 0, 0, and I need a slope. From this point to this point, or from this point to this one, I guess I could say, we are rising 1, running negative square root of 3. So our slope is rise 1, run negative square root of 3, or fall 1, run positive square root of 3, negative square root of 3 on 3. So our equation is y minus 0 equals slope negative square root of 3 on 3 times quantity x minus 0. And that's it. And to be honest with you, this one even easier. I can rotate pi on 2, face this way, throw the rock as far as I want, forward, Or backward, the equation of this line in rectangular is just x equals 0. Wherever we go on that line, x is 0. Okay, I should be having you pause and try some of these. If 65 made some sense to you, you should be able to do 71 right now, or at least get it started. Let's give that one a shot. Pause if you haven't. Give it a try. If you have paused, welcome back. R equals -3 times R on Y, cosecant's 2 a.m. wake-up call. I'm going to divide both sides by R, and I get 1 equals -3 on Y, or Y equals -3. Wow, doesn't get much more simple than that. And think about that one. The graph of cosecant, plain old cosecant, looks something like this. On and on we get these values, but if we turn that into a polar form with cosecant, it actually just becomes the graph. It would look just like the rectangular, y equals -3. All right. R squared. R squared is a gift. That is x squared plus y squared equals cosine. What do we do with trig functions? We 2am them. That's x on r. So that's half good, half bad. I mean, I got x's and y's. I've got an x, but I don't like this r. I need to convert that r. So maybe what I would do is multiply r to the other side and get r times x squared plus y squared equals x. Maybe I would divide, get r alone. R is x on x squared plus y squared. And now I don't have much choice other than to square both sides. So I get r squared equals x squared on quantity x squared plus y squared squared, squared both sides. Convert this to x squared plus y squared equals. And now maybe multiply both sides by this denominator, and I get a pair of x squared plus y squared factors times another one of those. I get x squared plus y squared cubed, two of them times one of them, cubed equals x squared. And I don't know if we're going to do much better than that, trying to superfoil that out, simplify things. I think that's probably it. Okay, 75. We are going to skip. Back in the section when we learned double angle identities, for instance, sine of 2 theta equals 2 sine of theta cosine of theta, it talked about multiple angle identities beyond that, and we have not studied that yet. It's really not imperative for you at this time. You won't even use that in calculus, more than likely, or Calc 2 even. It would be more of a trigonometric deeper study. So by the time you would get to a course that uses that, you would need to relearn it anyway, most likely. So let's pick it up at 77. 77, I'm not going to square both sides first. I'm going to do my 2 a.m. wake-up call first. So here we get r equals 1 on 1 minus cosine x on r. Let's cross multiply. I get r times 1 minus x on r equals 1. Distribute. I get r minus x equals 1. Now let's isolate r and square both sides. Add x joins a plus 1. So I get r squared equals x plus 1 squared. Let's see, that's x squared plus y squared. That's why we did it. Equals, and you could leave this, but again, I'm going to try to see what this ends up being. This is x squared plus 2x plus 1 foiled. Oh, the x squareds cancel. I get y squared equals 2x plus 1. And I realized, oh, okay, by that point, I recognize, hey, this is a parabola. This is a y-squared parabola. It's a positive one. It's a parabola that opens up to the right. We could maybe go for standard form of a parabola here, and then we'd know exactly how it's shifted. And, but anyway, that's probably the solution that I would be happiest with. Okay, if you got 77, then you should be equipped to try 79. So pause the video, try that problem. They're very similar. So here we have r is 6 on 2 minus 3 times y on r. Let's cross multiply. R times 2 minus 3y on r equals 6. Let's distribute 2r minus 3y equals 6. Let's go r equals, add 3y, joins a plus 6, divide 2. Let's square both sides. We get r squared equals 3y plus 6 squared on 4. Excuse me, that's x squared plus y squared. I'm healthy. X squared plus y squared equals, let's go, 9y squared plus, let's see, 18, 36y plus 36, all on 16. Maybe I'll multiply that 16 across, because I had to, oh wait, I've already squared that. I already squared that 4. Multiply that 4 across, excuse me, 2 squared 4. Okay, so what do we end up with here? 4x squared plus 4y squared is 9y squared plus 36y plus 36. And from there, I probably would be tempted to do this. 4x squared, subtract 9y squared, minus 5y squared, maybe minus 36y equals 36. At this stage right here, I'm recognizing that unless this is undefined somehow or another, it can't work, then this would be a hyperbola. And I could go through the process of putting this in standard form. It would be a mess. And I would have to factor out a -5 here. And then you can see that's not the most pleasant thing to do here. Complete the square. It would be a messy hyperbola is what we would end up with. Alrighty. And these ones, pretty friendly. I mentioned earlier in this set that if you're given just an r or just a theta, and we wanted to convert those things, best thing to do is just graph it. So r equals 6. What does that mean? That means it's the points. Yep, that's right. 6. And how do we want to rotate? We can rotate anywhere we want, and then we're going to throw the rock 6. We're going to throw it 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 up 6, down 6. We're going to throw it 6. So we just have a circle. Describe the graph of the polar equation and find the corresponding rectangular. Well, the rectangular, I mean, I could square both sides if I wanted to and change that to x squared plus y squared. Well, let's do it. That's r squared equals 36. X squared plus y squared equals 36. But couldn't we have gotten that from the graph? So describe it. Well, wow, this really describes it, but it's a circle, center 0, 0, radius 6. Okay. Theta equals pi on 4. Rotate, so that's, throw the rock any distance you want, you just have to rotate pi on 4. So we throw pi on 4, so we're throwing it out this way, or The backwards version of that, we could aim this way, throw the rock backwards, because r could be negative. R doesn't have any restriction. So this is just the line y equals x. So I guess it's a line, I'm going to say maybe through the origin with slope 1. That's a pretty reasonable description of it. And r equals 3 secant. And I can take you back to a problem that we had that was very similar to that back on 71. So if you're here for number 85, you could look at 71 and model it after that. Try that if you're here for 85. Welcome back. I'm going to 2am this. R equals 3. R on x. The r's cancel. I get 1 equals 3 on x. I get x equals 3. And therefore, our line looks like this. Describe it. I guess I would say it is a vertical line passing through, for instance, 3, 0. Okay, and there you have it. That's the wrap-up for 9.5. Stay well. Let me know if I can help you with anything, and good luck.